Okay, so this is page 30 in your packet. Okay. Those of you joining online. Okay, so let's look at number 7 here. It says the position function of a particle moves along a coordinate line, so it's moving x along horizontally. X of t equals 2t cubed minus 21t squared plus 60t plus 3. Feet in x is in feet, t is in seconds. Okay, so part A, what is a particle at rest? So how do we interpret that? Particle at rest means what? Yeah. Means what? 0.
X equal to 0.
X of t equal to 0?
Or
V of t equal to 0, right? So velocity equal to 0. So we have to find velocity first, set that equal to 0, and then we can move on, right? So to get to velocity, okay, what's our derivative here?
6t squared.
Okay.
Minus 42t plus 60.
Good. Linear goes to a constant. The 3 drops out, goes to 0. Okay, we can set equal to 0. I can do some factoring, right? Take out the 6. Multiplies to be 10, adds it to be -7. Okay, so we get t equals 2 and 5. Okay, when is a particle reverse direction? So we're going to have to create our number line, right? Our velocity number line. In this case, okay, let's say that they did not provide any restrictions, so that's going to be for all real numbers then. Okay, we place what we found. We place where values where or t values where the object is motionless, so that we know that in each of these subintervals the object is moving, right? And it's going to be moving in a consistent same direction in each of the subintervals. So we can test values, right? So what value can we test here? What's an easy number we can test here? A 1, yeah. We can test 3. We can test 6. Now, these numbers are not going to be used anywhere else except to fill out the signs. After fill out the signs, then we don't care about the 1, 3, and 5 anymore. Okay, we're using the 2 and 5 and the infinities. So 1 gets inserted into the factored form of your velocity function. So 1 minus 2, negative. 1 minus 5, 2 negatives makes positive. Plug 3 in, 3 minus 2, positive. 3 minus 5, negative. 6 minus 2, positive. 6 minus 5 is positive. So we have all these intervals of positives here. So reverse direction is at 2 and 5 because my velocity changes signs. Okay, what is the velocity when acceleration is 0? So we'll first find when acceleration is 0. So we'll find acceleration. So we go from velocity, derivative, down to acceleration. set acceleration equals 0. Factor a 12 out. Oh, I'm sorry, I can't factor a 12 out. I can factor a 6 out, sorry. 6 goes in the 2, but not 12. The 6 we could ignore. There's no variable there. We can just set 2t minus 7 equal to 0. So now that we have the time when acceleration is 0, how can we find the velocity?
Okay.
Yeah, plug 7/2 into the velocity function. Okay, so it's a little messy algebraically, but so 3.5, I'll put in the factor form here. 3.5 minus 2 is 1.5. 3.5 minus 5 is negative 1.5. Ends up being negative 13.5. Units of measure is feet per second, since velocity is change in distance over change in time. Part D says, what is the speed when acceleration is 6 feet per second? Let's not worry about speed just yet. We can just worry about something that's related, that's more connected to us. What's related to speed? Yeah, speed is similar to velocity, right? So it's just the positive version of velocity. So let's just worry about velocity first, since we have equations for it, and then we can turn around and figure out the speed. So let's rephrase the question. What is the velocity when the acceleration is 6 feet per second? So same process, right? Replace your acceleration with 6 instead of 0. And then we can solve for t, and then we can plug into for velocity. Right. Got a handout there. Oh, sorry, over at least. Yeah. So we know the time when this object has an acceleration of 6 feet per second. Let's find the velocity. So we'll find v of 4. I like to put it in factor form, which is easier dealing with smaller numbers here. So 6 times 4 minus 2, which is 2. 4 minus 5, which is negative 1. So my velocity is negative 12 feet per second. Okay, so we're almost there. We found velocity, so how can we adjust that to produce the speed? What's the relationship? Yeah, it's the absolute value of velocity. So my velocity is negative, then my speed is just the positive version of velocity. Okay, what is displacement? I'm going to review this in class. Displacement is how far you are from where you started. Okay, so displacements and distance, displacement, we only require position. So we just have to figure out where we are at 1 second, where we are at 3 seconds, and then we're just simply subtracting that distance. Okay, whatever we get from our final position minus our initial position, that is our displacement. So if I insert 1 into the position function, I get 2 minus 21 plus 60 plus 3, and I'm going to do the math for us, ends up being 44. Okay. So that means 1 second in, this object is going to be on the x-axis at position 44. X of 3, we can plug 3 into the original function to find the location of this object. So 2 times 3 cubed minus 21 times 3 squared plus 60 times 3 plus 3. The numbers will be easier on the quiz, but I just want to go through this example. It's 48. We plugged it into the position function. So displacement, the formula for displacement is just final position minus the initial position. Whatever the final is and the initial from your list of t-values. So it's just x of 3 minus x of 1. If it ends up being negative, then that's fine. Then that means we end up to the left of where we started. But here, 48 minus 44 is 4 feet. Now, all this means is between 1 and 3 seconds, this object is going to end up 4 feet to the right of where you started. That's all it means.
You plugged both the x3 into the top of the.
Yeah, you plug both 1 and 3 into the position equation. Yeah. So displacement, you're just playing with position. You're not playing with velocity or acceleration. Now, total distance requires a bit more effort because we have to potentially count. If an object is moving back and forth, we basically have to count the steps, right? So any steps that this object takes, we're going to count towards positive. So if he's moving backwards, we got to count that as a positive step. So the best way to do that is look at the velocity sign line to figure out, does he even change direction between 1 and 3? And does he change direction between 1 and 3 seconds?
Yeah.
Yes, right. And also, we don't look at these anymore because those are just for if we're running statements of intervals of increase, decrease, or to the left and to the right, we use 2 and 5 infinity. We don't touch the 1, 3, and 5. So what we need to do is we need to find out where he is at 1 second, find out where he is at 2 seconds, and find out where he is at 3 seconds, because we want to figure out how many steps is he going to take, because we know he's going to go back and forth. We can't just do 48 minus 44 because he's taking more steps than that. So what you're going to do is you're going to find his location at his starting points and at the place where he changes direction. So here, in this case, x of 1, x of 2, and x of 3. So x of 1 is 44. We already found that. X of 3 is 48. X of 2, that means he's going to be at location. So plug 2 into position here. So 2 times 8 minus 21 times 4 plus 60 times 2 plus 3. I'm going to speed that up here. That ends up giving us 55. So imagine a number line here where he's at location 44. He goes to location 58, and then he goes back to location 48. So he's doing this. From here, he's going to there, and from there, he's walking back to 48. So we have to basically figure out how many steps is he going to take from 44, sorry, not 58, 55. So from 44 to 55, how many steps is he going to take to go from here to here? 11, because 55 minus 44 is 11. So we're going to end up subtracting, okay? Subtracting. And we're always going to think in terms of positive, because I want you to think in terms of distance. Just imagine you're walking, right? When you're walking and you're counting your steps, you're never going to count negative, right? You're only going to increase the number of steps that you take. So everything is positive. So from 44 to 55, you're taking 11 steps. And then from 55 to 48, how many steps is that? 7, all right? So then how many steps have you taken if you go from this location to this location back to this location? 18. So distance is 18 feet. Does that process make sense? We're not purposely trying to test every integer value between 1 and 3. It just so happens that there's a change in direction at 2. If there was no change in direction, then we can just do 48 minus 44, because the only have to worry about total distance if there's a back and forth movement. Okay, so let's look at this here. This is on page 34. It says find the following. Let's say I gave you a bunch of these values already. Let's say I gave you position at 2 and 4. I gave you velocity at 2 and 4. I gave you velocity at 6 and acceleration at 4 and 6. These are the only values that we need. Don't have to worry about a formula to plug in, because I'm providing this for you to just to kind of help us see that process. So average velocity, let's think about that phrasing there. What does average velocity mean? Okay, so average velocity has a specific definition. The focus is on that word average, okay? And it's not instantaneous velocity, it's average velocity. So average velocity is defined as the change in position divided by the change in time. So are we going to touch the velocity function when there's average velocity going on? No, we're not going to touch velocity function. And that is what is so troublesome, I think, on the, not trouble, but it's a big cause for mistakes, because you see velocity and why not use velocity, right? But that's not the way that we define velocity, average velocity. So change in position over change in time. We have our locations. So what do you think we can use to find average velocity between 2 and 4? What information could we use to build this slope or build this rate of change? Okay, so what represents position here? That's my S. S is my position here. Okay, so S of t is position, V of t is velocity, and A of t is acceleration. So what would change in position look like?
Like 30.
It'll be S of 4 minus S of 2 divided by what? Yeah, 4 minus 2. So 40 minus 10 divided by 2. 30 over 2 is 15. 15 meters per second. Now, part B is asking for the instantaneous velocity. So now we can use the velocity function, right? Because now it's asking for the exact moments, the exact velocity at that moment in time. So this should be easy. What's the instantaneous velocity at t equals 4? Yeah, v of 4 is negative 12. So do you see that distinction here? These both involve the word velocity, but one of them uses velocity function, the other you don't. Okay. Is the velocity positive or negative at t equals 4? Negative. Okay. Part D, is the velocity increasing or decreasing at t equals 4? Is that the same thing as part C? Okay, what is this talking about?
It's going up or down.
Okay, but in other words, what is that increase, decrease? Is that talking about velocity or is it talking about something else? Acceleration, yeah. It's talking about the rate of change of velocity. And the rate of change of velocity is basically the slope of velocity. The slope of velocity is acceleration. So this is basically just asking about acceleration. So in other words, part D is basically saying, is acceleration positive or negative, but it's phrased in this way. Is velocity increasing or decreasing? So what do you know about acceleration at t equals 4? Positive or negative? Positive, therefore velocity is what? Increasing. Part E, is the speed increasing or decreasing? So this is a little bit different here. Is the speed increasing, decreasing? We have a formula for this. Do you guys remember what that formula is? Is the speed increasing, decreasing? We compare two things here. We compare okay, let me review here. This is on page 15. It says speed is increasing when velocity and acceleration have the same sign. Speed is decreasing when velocity and acceleration have opposite signs. Okay, so can I make a conclusion then? Is the speed increasing or decreasing at t equals 4? Decreasing because
The velocity is negative, the acceleration is positive.
yeah, velocity and acceleration have opposite signs. Okay, part F, find the average acceleration on the interval from 4 to 6. So if you know average velocity is change in position over change in time, what do you think the definition for average acceleration is?
Change in acceleration. Change in time.
Well, that's the thing, right? If that was the case, then average velocity would be change in velocity over change in time. Right, so no. So average velocity is really talking about rate of change of velocity, or sorry, rate of change of position. So what do you think average acceleration would be?
Velocity.
Change in velocity over change in time, right? So the slope of the function above it will describe that function, right? So velocity requires the function above it. Average velocity uses the function above it. Same thing, average acceleration uses the function above it. And what's above acceleration is velocity. So what would you use to build your average acceleration then? Yeah, so it says,
All right, the speeds.
Yeah, v of, right. I know the temptation is you want to use acceleration, but you see that word acceleration, but the definition involves just velocity, right? So yeah, so say it again.
V of 6.
Uh-huh.
V.
Yeah. Over 6 minus 4. So v of 6 is -4. V of 4 is -12. So 12 minus 4 is 8. 8 over 2 is 4. Now, even though we didn't touch acceleration, our units of measure is still in terms of acceleration, so it's 4 meters per what? Something else squared. Yeah. Okay, why don't we do 2 power rule problems? Okay, so let's use the back of this sheet here. So we want to clean everything up. Everything should be ready. We can, after we clean everything up, everything should be ready for us to do power rule. But a couple of things we got to take care of, right? We have some parentheses we have to resolve. We have some radicals that we have to rewrite. And then we have some variable denominator we have to push up to the top. Right? So I'm going to spend time to kind of fold this out. Now, x minus 1 squared is really x minus 1 times x minus 1, which is x squared minus 2x plus 1. Okay, so if I distribute a 3 through that, it's going to do that all at once here. So I just want to kind of because if I were to give this to you on the quiz, this is basically power rule, but how would you rewrite this so that the x doesn't have a root 11 underneath it? I could just pull this number out in front, right? It's a messy number, but it's just some coefficient. That way it just doesn't feel like I got to deal with anything messy like quotient rule, right? That's the same thing as this. Okay, next term, how would you rewrite this so that we can get it ready for power rule? What's the square root of x to the 5th? 5/2. And it's in the wrong place, so where would you put it? Would the 3 go along with it or would it stay? Stay. Okay. Now, e is just a number, okay? It's irrational numbers around 2.7, so just understand that. Okay, every term is set up nice and ready for us to apply power rule. Let's find the derivative. Okay, so every term, we're going to go through power rule. 3x squared becomes 6x becomes 3 goes to a 0. What's the derivative of 2 pi over root 11x?
0.
Now, you're going to treat the derivative of this the same way as 6x. If the derivative of 6x is 6, what do you think the derivative of 2 pi over root 11x is? I know pi looks like a variable, but it's just a number, right? This is just some ugly number in front of x. So 6x becomes 6. X is linear. 2 pi over root 11 is also some linear expression. That's the slope, right? The slope is just a number in front of my x variable. Does that make sense? Right. All right, next up. What's the derivative? How would you set this one up to do power rule? Okay, what's my new exponent? Yep, but you're subtracting 1, right? We always subtract 1 from the exponent. What do you think 4e squared becomes? Remember, e is just a number. Yeah, so any number, doesn't matter if it's squared, it's still going to be a number, right? Any constant will go to 0. And my -5 is also a 0. Okay, so we're just cleaning up here. Um, 20 over 3 can reduce to be 10 over 3. Or sorry, 20 over 6 can reduce to be 10 over 3. And I just want my exponent showing positive, so I'm going to push that x down below as well. Okay, let's do one more here. Okay, we're going to find the derivative here as well. Now, this looks messy. This feels like we have to go through quotient rule, but what is it about this problem that allows us to avoid quotient rule?
One term with nothing.
Good. There's only one term in the denominator. We can just go ahead and split this up into individual fractions. There's no need to treat this like one messy problem. We can break this down into 2 smaller problems. So I'm going to distribute through, get everything cleaned up, and see if I can move some stuff up to the top after I separate. So we're working on our cleanup stage here. Okay, I'll distribute the 3x through 3x to 1/2. So how do I merge these exponents here? Add them. So 1/2 plus 2. And then I can also split up into individual fractions, right? So we can treat these like individual problems, but obviously we want to take the time to bring the x up. So we're still in our cleanup stage, no calculus just yet. I can merge these two variables by subtracting the exponents. So, or I can bring this x up as x to negative 5 halves and add the exponents, same thing. But I'm going to just leave it in this form here. What's 3 halves minus 5 halves? Yeah, negative 2 halves, which is negative 1. What's 1 half minus 5 halves? Negative 2. Now, some students feel like this can be their answer because you spent so much time and effort into cleaning up that we forget that we haven't done the calculus yet, right? This is only to the starting line, right? We still have to get to the derivative. So now we can go through power rule, right? Now we can do dy dx or y prime. Okay, so power rule derivative. So now we have our answer. We're doing cleanup. So we pushed our x's back down to our denominator. Six over 4, same thing as 3 over 2. Now we have our slope formula. Okay, we're starting a new section today, but we can go back and we'll do one of the there's one more review sheet in the packet, and I'll give you another one for us to do together Friday morning. Okay. All right. Let me know if you have any questions.